Sorry about that. I had to tell the custodian not to clean my room while I was talking to you guys. So, anyways, let's finish this. So, we're going to graph the second equation here, 2 to the x minus 4. And for this, we have to use x values between 0 and 3. So, let's just do 0, 1, 2, and 3. So, plugging these in, we're going to plug in 0, 1, 2, and 3. At 0, it says it must just be a less than 0. So we're going to do an open circle at 0. At 3, it has to be less than or equals to, so we're going to do a closed circle on 3. So remember that when we go to plot the points, we have an open circle on 0 and a closed circle on 3. Okay, plugging in 0, we have 2 to the power of 0 minus 4. Anything to the power of 0 is 1. So that's 1 minus 4, which is negative 3. Then we have 2 to the power of 1 minus 4, which is negative 2. And then we have 2 to the power of 2 minus 4, which is 0. And then we have 2 to the power of 3 minus 4, which is 4. Okay, so that was our second equation for points between 0 and 3. The last one that we have to graph is 2x minus 2. And we graph 2x minus 2 if our x values are greater than 3. So it's not an or equals to here. So even though we're going to plot 3, it has to be an open circle on 3. And it's any x values greater than 3. So 3, 4, 5, 6, things like that. So the last one we're graphing is 2x minus 2. And we're graphing this for x values that are greater than 3. So x, y. So we can do like 3, 4, and 5. But it's not or equals to 3. It's just greater than 3. So we have to have an open circle on 3. All right, so plugging this in. Plugging in 3 for x becomes 2 times 3 minus 2, which is 6 minus 2, which is 4. It becomes 2 times 4 minus 2, which is 8 minus 2, which is 6. And 2 times 5 minus 2, which is 10 minus 2, which is 8. Okay, now we have a bunch of different points that we should plot. So make your little graph here. This is the y-axis. It's a pretty straight line. Good job. Okay, this is an x-axis. And on the x-axis, I'm going to count by ones. So 1, 2, 3, 4, 5, 6. In the y-axis, I'm going to count by twos. So 2, 4, 6, 8, 10, 12, 14, 16. Okay. Now we have a bunch of coordinate points to plot, like 0, 0, negative 2, 2, 2, 0, 5, 8. So we have a bunch of different points to plot, so let's just start plotting them on the graph. So 0, 0 is 1 point, and it has to have a closed circle. So 0, 0 is right here, and it is a closed circle. Negative 1, 0.5. So negative 1, 0.5 is about right here. Negative 2, 2. So negative 2, 2 is right here. And negative 3, 4.5. So negative 3, 4.5 is about right there. So there is one of my graphs. Draw a little arrow going out. Okay, graphing the second one. We have 0, negative 3. 0, negative 3, but we have to have an open circle there at 0, negative 3. And then we have 1, negative 2. So 1, negative 2. 2, 0, which and 3, 4. So 3, 4, which is right here. Okay. For this one, we just connect our dots. Don't put an arrow on the end because this doesn't go on forever. This graph is only between 0 and 3. So don't put an arrow on the end of that one. And now we have to graph the last one. The last one, 2x minus 2, we have to plot 3, 4. Well, we already have a point at 3, 4. Even though this one's supposed to be an open circle, there's already a point there from the previous graph, so we'll just put another point there. So 3, 4, 4, 6. So 4, 6. And 5, 8. So 5, 8. Go ahead, connect those points. Now this does get an arrow on the end because it goes on forever because it says anything greater than 3. So it just continues on anything greater than 3. At this point, that's our final graph. So we have 3 different equations on the same graph. Looks pretty good. All right, the next 2 pages, I want you to try the next 2 problems. You're doing 2 things. You're plugging in values, and then you're actually graphing. Check the answer key on Blended Schools. So there is a 6.1 Day 1 teacher answer key on Blended Schools. Please check it. We'll talk about this stuff more tomorrow. All right, guys. Have a good day. I'll see you tomorrow.